Hello, this is Miss Dagenford, and I wanted to share with you today the different circulatory systems. And so, again, you can hit pause as you guys are perhaps thinking about this as a class. Some of the things that you already know about the circulatory system in us, in our bodies, and maybe think about some of the different parts, its a purpose and function. So go ahead and discuss. And okay, good. So hopefully you had a good discussion about it, and you probably remember from your middle school days that the circulatory system is going to be there to deliver oxygen and remove carbon dioxide. Now, give it a few seconds thought as to where we want oxygen to get to, and where we want to take, and where we get carbon dioxide and where we take it to. So, okay, so you probably may remember that oxygen is going to be delivered to any part of the body that is using it, right? Your brain is a big user of oxygen. It loves oxygen, so much so that every single one of us probably has a story of somebody who has fainted. And sometimes that's simply because they have low blood pressure and they're not getting the oxygen to the brain. And this could be simply an emotional upset. Some people get very nauseous. That lowers their blood pressure. That affects their oxygen getting to their brain, and down they go. And so that really does affect things. So, any part of your body that is going to be actively working, your muscles, your digestive system, that needs oxygen. And then carbon dioxide is going to be produced by those systems. And then your circulatory system is going to take it to the respiratory system. So there's a very tight relationship between circulatory system and respiratory systems, and we see that in their size and complexity and amounts of surface area, right? Because if you're getting more oxygen, then you need a system that can deliver that, right? All of these delivery companies that we have out there, FedEx, Amazon, Post Office, it doesn't do you a darn bit of good if you're getting a lot of packages, but you don't have the means to deliver them. So if you've got a complex respiratory system, then you're going to see a complex circulatory system to go along with that. So some of the parts that you're probably familiar with, we've got the heart, which is a muscular pump, and it contracts to push blood to create a pressure and pump blood. I don't think that should be a surprise to anyone. Now, most of the hearts that we're going to looking at in vertebrate systems, they have at least one atria. An atria or atrium, they are chambers that receive blood from the body. They generally are a little weaker. They're not the big push. So what they pretty much do is they collect the blood and then push it into the ventricles. The ventricles are the big push chambers. They are the bottom chambers. I like to remember A is on top in terms of the alphabet, and then V is on the bottom alphabetically as well. So atria are generally on top, at least for the human heart, and then V would be on the bottom. Now, arteries are going to be found coming out of the heart, and arteries are under high pressure, and they, by definition, they take blood away from the heart. And so there is one exception to, you might remember that arteries always carry oxygenated blood. You're generally correct, but the proper definition is arteries take blood away, arteries away. And the reason for that is there's a pulmonary artery that takes blood away from the heart to the lungs. And so that means the pulmonary arteries are low in oxygen. Yeah, I know. It can be frustrating. So arteries are taking blood away from the heart. That's their primary definition. The vast majority of them do carry oxygenated blood, and we see them being under higher pressure. Certainly the left side of the heart is under higher pressure. Capillaries are going to be extraordinarily thin, one cell, and that allows for diffusion. And we have a lot of them. And if I had to ask you why, I bet you could start to think, gee, what does she want me to say? It's the surface area again. The more capillaries, the more you're spreading out the blood vessels and the blood, and the more oxygen can be delivered. What's interesting as well about the capillaries, the blood slows down drastically. And in fact, arteries are very fast, capillaries come to a crawl. And that makes sense. If you're delivering something, you're not going to run screaming by, hoping the oxygen diffuses out. They slow down, it allows for diffusion. And then as the blood is now oxygen poor, the veins are much slower, there's less pressure. We also now have valves because there's less pressure. The blood can backflow. And so we're going to take the blood back to the heart. So what we're going to notice in vertebrate systems, again, the bigger you are, the more metabolism you have, the more active you are, the more power and muscles you have, the more oxygen you need. And that's going to be reflected in the circulatory system. So over on the left, you see the simplest, and that would be in fish and tadpoles. They only have two chambers, one atria and one ventricle. And what you will notice is they also have what's called a single loop, only one loop around. Now, this can be a little too simplified, these drawings, because it kind of makes it seem like it's just one great big circuit. In its entirety, it is one big circuit, but you would have veins going to fins, different organs. The point is, though, you go from the heart to the gills to get oxygen, and then the blood is just going to continue and deliver to all of the systemic capillaries. All that means is that blood is going to go to every bit of the body that needs oxygen. Heart itself, lungs, stomach, kidneys, fins, muscles, they're going to go to all of the different systems. And then they're going to come back to the heart and then get kind of propelled again. So that's a single loop. It's got two chambers, one atria, one ventricle. Not as efficient. Now, fish have the buoyancy of water. They don't need to put a lot of energy in supporting themselves, but they do have some, activity, and, but that buoyancy of the water really can help with the amount of oxygen they need. They don't need to spend a lot of energy in just muscular support for posture. And then the amphibians and small reptiles, we start getting a little bit bigger heart and more chambers. Generally, we see three chambers, two atria and one ventricle. As we start getting into reptiles, the ventricles start getting somewhat closed, and so we don't quite have the same mixing. Amphibians, the oxygen poor and oxygen rich blood mix together, and so it's a little less efficient. Now, what you start seeing in the tetrapods is a double circulation, a double loop circulation. And what that simply means is one system is going to go to the pulmonary, or in the case of the amphibians, the skin, the pulmonary cutaneous, because they can absorb oxygen through their skin as well. So one side of the heart is going to be devoted to squeezing and taking to the pulmonary, the lungs, and then the other is going to loop to the tissues. Now what this means is now you have a dedicated part of the heart that is going to push the oxygenated blood a little bit better and give that extra pressure to the system. And it's going to be more efficient. And so that's what we're going to see at this point on. So double loop, you get one loop to get oxygen, then you're going to come back to the heart, and then you're going to deliver the oxygen to the systems in the body. Reptiles, again, you're going to see some mixing, but it's going to, especially when you get to crocodiles and larger reptiles, you start to see partial four chambers. And that is going to, again, help them be a little bit more efficient. Birds and mammals and large reptiles are going to have the four chambers. And now you have a proper efficient system. You've got what is essentially two pumps. The right side, now I know if you're watching this, you should be thinking, wait a minute, that's not the right side. This is the right side as the animal is looking at you. So this is the right side, and it's going to take the blood to the lungs, come back, and it's completely separate. And that left side of the heart is going to be more muscular, and it's going to squeeze more forcefully, and it's going to eject blood with a lot of force and go to the different systems. So much more efficient, and again, more oxygen, more metabolic activity makes sense. So again, large reptiles, birds, I should add in there, and then mammals are all going to have that four-chambered heart, and it's going to have two atria and two ventricles. And then a quick word about the cardiac cycle. This is, again, our four-chambered heart. The right side, remember, is going to be the oxygen pour. The blood is never blue, by the way. That's a big myth. If you were thinking that, get rid of that. The blood is at the most oxygen pour, it can be like a very deep, dark red. But it's not blue. It's never blue. This is just a convenient picture to help you see the difference. So the right side is carrying oxygen poor blood. That's going to be taken to the lungs. Left side is getting oxygen-rich blood from the from the lungs, and then it's going to go to the body. But notice the way the heart beats. The top two chambers contract, and while the top two chambers are contracting, the bottom two, the ventricles, are relaxed. And that makes sense, right? If you're going to fill the ventricles, then you need the ventricles to be relaxed. So the cardiac cycle, there's actually 3 steps, but there's 2 that are real obvious. One's part of the cardiac cycle, the atria squeeze, push blood down, and then as the blood is pushing down, the ventricles are relaxed. And then as the ventricles fill, they're going to then contract and push blood up. And so you'll notice that repeated squeezing and pushing, atria push down, ventricles push up and out. And those are the 2 main cycles. Like I said, there's a third one, but it's a little less and it's a little more subtle and more complicated. We don't need to worry about that. So the heart works in synchrony. Both atria contract, and then both ventricles contract. And that's going to be true for all mammals and birds. And within the same context, but with fewer chambers, you see that in some of the other heart chambers as well. So that gives you a really nice introduction, hopefully, to the cardiac, the circulatory systems, and I hope that helps.